Hello everyone, hope you doing well. My name is Tawfiq Omer, math teacher. In this video I will explain chapter 1, lesson 3, part H, transformation of functions. Please do not forget subscribe the page and write your comment if you have, and press the like button. Thank you for that, and be careful, there is a link of exercise for the chapter 1 lesson 3 in description below. Transformation of functions. Moving the graphs of the basic function to the left or right or up and down, we get a new function. This process is called transformation. You can see in this graph, if we move it, this basic function fx equal x squared to the right 1 unit, then the function is changed to fx equal x minus 1 square. And if we move it 2 unit, therefore it become fx minus 2 square. And if we move it 3 unit, therefore fx equal to the x minus 3 square. And now if we move it to the left side, you can see that the function changes to fx equal x plus 1 square. If 2 unit, it become fx plus 2, and 3 is x plus 3 square. And now if we move it up or down, it become fx equal x square plus 2. We add 2 to the function if we move it 2 unit. If we move it 3 unit, we add 3, etc. And if we move it to the down, then x square minus 2, x square minus 2. If we move it 1 unit to the down, then fx square equal fx is square minus 1. And then if we 2 unit, therefore it become x square minus 2, etc. That's the meaning of transformation. If we have an original function y equal fx, the first transformation is an horizontal shift c unit to the right. Then y equal fx become y equal f of x minus 2. In this case, we subtract the value of c from x. Subtract the value of c from x. If we take fx equal x square and draw its graph, is like this. If we move this graph to the right 1 unit, fx is become fx equal x minus 1 square. That the point A goes to the point A dash. A is 1 1, A dash is 2 1. That means we added 1 unit to the x. We added 1 unit to the x. The function fx equal to x minus 1 square, then the point a is 1 1 and a dash is 2 1. And if we move it 2 units to the right, therefore the function become here and it become x minus 2 square, and the point a goes to the point a dash. A is 1 1 and a dash is 3 1. We added 2 units to the 1, which is x. If we continue it in this way, so that any point like axy moving to the a dash a plus cy, we adding c to the value of x. Example number 1. The transformation that transforms the graph of the function fx equal absolute value of x to the graph of gx equal absolute value of x minus 5 is here in the green color. The graph of the function fx equal absolute value to the x, and here we have the graph of the function gx equal x minus 5, absolute value of x minus 5. Because the g is in the right of the fx, therefore we must move the graph of the fx to the right. Here 1 2 3 4 5. That means to find the graph of gx, we must move the graph of fx 5 units to the right. 5 units to the right. A is correct answer. The second transformation is horizontal shift c unit to the left. The original function y equal fx become y equal f of x plus c. And if we take the basic equation of the quadratic function fx equal x square and draw it like this, and moving this function 1 unit to the left, it become fx equal x plus 1 square, and the point a 1 1 goes to the a dash 0 1. That means we subtracted the value of c from the value of x, or subtracted 1 from 1, then 1 minus 1 is 0. And in the second time, if we move it 2 units to the left, it become here. Therefore the equation become fx equal x plus 2 square, and the point a 1 1 goes to the point a dash minus 1 1. Subtracting 2 units from x, which is 1, 1 minus 2 is minus 1. We can say that any point like a xy moves to the a dash x minus c y. In this case, we subtracting the value of c from the value of x. In the horizontal shift transformation, only the value of x change. Example number 2. The transformation that transforms the graph of the function fx equal absolute value of x to the function gx is equal absolute value of x plus 5. We can say, because we have here x plus 5, that means 5 units to the left. If it was positive, it is to the left. If it was negative or minus, it is to the right. That means C is correct answer. And if we see it in the graph, this is the graph of the function fx equal absolute value of x, and this one is the graph of the gx, which equal absolute value of x plus 5. If we want to find the graph of gx moving fx 5 unit, 1, 2, 3, 4 and 5, that means we are moving 5 units to the left to find gx. That means C is correct answer. Another transformation is a vertical shift C unit upward. The original function y equal fx become y equal fx plus c when c is bigger than 0. If we take the basic function fx equal x squared and move it 1 unit upward, become like this. The equation of this function is fx equal x squared plus 1, and the point 1 1 goes to 1 2. We add it to the y 1 unit, it become 2. The equation fx is equal x squared plus 1, and the point 1 1 goes to a dash 1 2. And if we move it 2 units to the upward, it become like this, and the equation fx changes to x squared plus 2, and the point 1 1 become 1 3. We added 2 to the y, which is 1. 1 plus 2 is 3. fx equal x squared plus 2, and the point 1 1 goes to 1 3. Any point like a xy moving to the a dash x y plus c. Here the value of y is changed. In this case we add the value of c to the y. Example number 3. The transformation that transforms the graph of the function fx equal absolute value of x to the gx equal absolute value of x plus 3 is, as you can see, we added 3 to the absolute value of x outside of absolute value. That means 3 unit to the upward. That means D is correct answer. And if we see the graph here moving 3 unit, 1 2 3 unit, and we get the graph of gx. And another transformation is a vertical shift C unit downward. Then the original function y equal fx become y equal fx minus c. That means we subtract the value of c from y. If we take fx equal x squared and move it to the downward 1 unit like this, equation of the function fx is equal x squared minus 1, and the point 1 1 goes to 1 0, because we are subtracting 1 from 1, because we move it 1 unit to the down, therefore subtracting 1 from the 1, or subtracting the value of unit from the value of y here. Therefore 1 minus 1 is 0. Y is 1, minus 1 is 0. And if we move it 2 unit, the equation become fx equal x squared minus 2, and a dash become 1 minus 1, because we move it 2 unit downward. Therefore y, which is 1 minus 2, is minus 1. Point a 1 1 goes to a dash 1 minus 1. In this case we subtract the value of c from the value of y, so that any point like a xy moving to the a dash xy minus c. In the vertical shift, the value of x not changing, but the value of y is changed. Example number 4. The transformation that transforms the graph of the function fx equal absolute value of x to the gx, which equal absolute value of x minus 3. Because absolute value is minus 3, therefore the transformation is downward 3 unit. And if we see in the graph of the function, this is the graph of the fx and this is the graph of gx. To take fx to the gx, we must move it downward 3 unit, like this. 1, 2, and 3. 3 unit. That means B is correct answer. Example number 5. Drawing graphs using transformation. Draw the graph of the function gx equal absolute value x minus 2 plus 3 using the graph of the function fx equal absolute value of x. If we have an absolute value of x to draw graph of gx, as you can see that we have 2 unit right, because x minus 2. We are moving this graph 2 unit to the right. Therefore, it become here 1, 2. And because the absolute value is plus 3, we have an 3 unit upward. 3 unit upward. Therefore, 1, 2, 3. 1, 2, 3. This is the graph of the function g of x. Example number 6. Graph of y equal fx is given. The equation of the graph of b is, this is the graph of fx. We want to find the equation b, the graph of b. The graph of b is at left side of the graph of fx and downward. Therefore, we can move the function fx to the left 3 unit. 3 unit. 1, 2, 3. And move it downward 2 unit. When we moving it horizontally 3 unit to the left, then y equal fx become y equal f of x plus 3. And when we moving it vertically 2 unit to the downward, after that, therefore y is equal this function minus 2, fx plus 3 minus 2. Is C is the correct answer. Another transformation is reflection. The reflection about the x-axis, the original function y equal fx become y equal minus fx. In this case, only the sign of y is changed. If we take fx equal absolute value of x minus 3 plus 1 and draw it, this is the graph of this function. And now, by reflection about the x-axis, these graphs become like this. Point A is 1, 3. Here, point A dash is 1 minus 3. That means the sign of y is changed. And B is 3, 1. B dash is 3 minus 1. Again, the sign of y is changed. And at D, 4, 2, and d dash is 4 minus 2. Again, the sign of y is changed. In this case, only the sign of y is changed. Fx become multiplying this function absolute value x minus 3 plus 1 by minus become minus multiply the function, and opening this bracket it become minus absolute value x minus 3 minus 1. Any point like a xy with the reflection about x-axis transforms to the a dash x minus y. With the reflection about x-axis, only the sign of y is changed. Example number 7. The transformation that transforms the graph of the function fx equal absolute value of x to the gx equal minus absolute value of x minus 1. As you can see here, that absolute value of x is multiplied by minus. That means is reflection about x-axis. And after that, we subtract it with 1. That means vertical transformation 1 unit downward. It means the transformation which make gx is reflection about x-axis and 1 unit to the downward. That means A is correct answer. And if we draw a graph of fx, the first thing to find gx, we have minus absolute value of x, reflection about x-axis, like this. And then minus 1, that means taking it down 1 unit, like this. This is the graph of gx. This is the graph of gx. A is correct answer. Another transformation is reflection about the y-axis. The original function y is equal fx become y equal f of minus x. As you can see here, the sign of x is changed. If we take fx equal absolute value of x minus 3 plus 1 and draw its graph by reflection about the y-axis, it become like this. The function become absolute value of minus x, only change the sign of x. X here positive, here is negative, and all points at all points change the sign of x. 1 3 become minus 1 3, 3 1 become minus 3 1, and 4 2 become minus 4 2. Any point like a xy with the reflection about y-axis transforms to a dash minus xy. In the transformation about y-axis, only the sign of x change. Reflection about the original point. The original function y is equal f of x become y equal minus of minus x. As you can note that the sign of x changed and the sign of y changed too. And this function is by reflection about original become here. That means fx is become minus bracket absolute value of minus x minus 3 plus 1, and all points change their sign of x and y. As you can see, a become 1 3 become minus 1 minus 3, b is 3 1 become minus 3 minus 1, and d is 4 2 become minus 4 minus 2. Therefore the function fx become minus absolute value minus x minus 3 minus 1, and all point, as we said, change their sign of x and y. Example number 8. Which of the following is the equation of fx? First of all, this is the quadratic function. Let us draw the graph of the basic quadratic function, which is y equal x squared. As you can see that this wanted function is opposite of given function. Therefore, it is an reflection about x-axis. Then we reflect this function about x-axis. It becomes f of x equal minus x squared, like this. And if we looked about the vertex of this function and the vertex of this function, this is right of this one. Therefore, we must move it 1 unit to the right. And this function f of x changed to the minus x minus 1 because we move it to the right horizontally. Therefore, the value of x is changing, x minus 1 square. And as you can see, the vertex of this is above this one. Therefore, we must move it upward 2 units. Therefore, it become here. And the function fx equal minus x minus 1 square become minus x minus 1 square plus 2. D is correct answer. Example number 8. What is the transformation that transforms the graph of the function fx to the graph of the function gx? As you can see, both of them is opening up. That means we have no reflection about x-axis. But the graph of gx is the left side of graph of fx. Therefore, we must move it to the left. And gx is down of fx, and we must move it to the down. That means we have two transformation. One of them left and the another is to the downward. The horizontal shift 2 units to the left, and this 3 units to the downward. Therefore, the transformation which leads fx to the gx is vertical shift 3 units to the downward and horizontal shift 2 units to the left. That means B is a correct answer. Here we reached the end of the lesson. Hope you will share it with your friends for benefit all of them, and subscribe my page and ring the bell and press the like button. Thank you for watching. Please be careful, there is a link for the exercise of the lesson down in the description. Download it and use it correctly to take more information. Again, thank you for watching and goodbye.